Okay, let's get started. So today's recitation is on Proxy Lab. So congratulations, you've made it through Malloc Lab, and now you're on to your very last lab of the semester, Proxy Lab. So what we're going to talk about today, we're going to talk about some of the tools that will be useful for you when doing Proxy Lab. We're going to spend a bit of time on that. We're going to talk about networking, how the internet works, Proxy Lab itself, and some stuff that will be helpful to you to complete it. So, okay, a couple details too about Proxy Lab. It's going to be due Tuesday, December 8th. So that's the Tuesday of the last week of classes. And you will be allowed to use grace days, since that's only partway through the week. If you have at least 2 grace days remaining, you can use up to 2 grace days on it and submit as late as Thursday with no penalty. In previous semesters, sometimes the due date has been later and we didn't allow grace days, but since it's Tuesday, we are allowing grace days this semester. So the internet. So if you look at a diagram in the textbook, you might see a simplified version of how the internet works. That looks something like this. You've got web clients, so typically that's your browser, although it could be other things, and we're going to show you a couple tools that can act as web clients today that aren't browsers. And then you've got a web server, so that's whatever server has the page you're requesting, and the web client asks for a page, and the server sends it back, and then the client knows how to display it. So if we have just this simple model, and we had a sequential server, this would be fine. We just ask for a page, we'd get it back one at a time, and that's not bad. But this is a simplified model, and the real internet is more complicated than this, and we'll be seeing what we actually need to do. So for Proxy Lab, you'll be writing a little proxy. So what is a proxy? A proxy acts in between. Is a layer in between these two guys. So you've got the client here and the server. In between them is going to be the proxy. What your proxy will do is it will take requests from the clients, which might be a web browser, and it will send them to the server, and then the server will send back the result to the proxy, and your proxy will then send it back to the client. And if, in the case that you ask for something you've already asked for in the past, you're going to be writing a caching proxy. So rather than sending the request to the server, again, your proxy will be able to send it straight back to your browser without that intermediate step. So what you'll be able to want to be able to do as you write this is you're going to need some tools to sort of test it before you get to the level of being able to just run it in your browser. I'll show you how to do that at the end. But there's going to be some tools that are going to be useful to you in order to test this lab and figure out how things are going on. Just play around with how these responses and requests work. So the first tool that might be very useful to you is Telnet. So Telnet is a way to interact with web servers just through text. It's kind of like a SSH session, except there's no security, and you're not actually like logging into a computer and running commands on it. You're just sending requests to a web server is what you'll be using it for. So you actually have to build the request manually. But that's a good thing. Once you get to your Proxy Lab, Telnet will be useful to you if you want to test that you can handle bad requests. Requests that a real web browser wouldn't make, but your proxy should be able to handle and not crash on. So to use Telnet, it's not too hard. So the name of the program is Telnet. And what you do is you put in the address and the port number of the, make it a little bit bigger. Put in the address and the port number of the guy you're trying to get to. So if we man Telnet, if you want to see all of the possible options, you can use the man page as always, and it'll show you all the different things we can do. What we're just going to do is we're going to use telnet, and we're going to say I want to get to example.com. 80 is the default port for normal HTTP connections. If you don't know what port you should be using, it's probably 80. And so what it gives us is now we're connected to the server. Example.com happens to be at this IP address. And we can send it now an actual request. So we're going to send it a GET request. The only thing your proxy has to handle is GET requests. You don't have to handle the other types. And we're going to say, I just want the main page itself. And we'll ask for the 1.0. And we hit enter and nothing happens. And that's because these requests are always terminated by a blank line. So the request isn't over until we hit enter again. If we wanted to add more headers, we can hit enter and just keep adding more headers. But this is the only one I want to send, so I hit enter again. And what does it give me? It gives me back the content of the web page. So this is the actual HTML for the web page. I don't have a browser open, so it's not gonna print it out, in the formatted, marked up way for me. It just gives me the raw text of the web page. So it told me, it got the connection okay. It gives me the date and time. Tells me some information about the headers it's using, and then you can see here that this is actually, if you opened up this page in your browser, you'd see this text, and it'd be all formatted with these tags. And then it closes it, and the telnet session is over. So we can do this. We can do this on other websites too. We could get a copy of the CMU website if we wanted. Do the same thing. So now we've got a copy of the whole CMU homepage, which is quite a bit bigger than example.com and has lots of stuff in it. And we could also send, we could also send bad requests with telnet if we wanted. So if we opened up CMU and then we sent it get random junk, I don't know if it's going to be mad about the semicolon. What does it do? Well, it tells us that it didn't know how to do it. So the server tells us, you sent me something that's junk. And so if you send bad requests or send requests with bad headers or anything of that sort in your proxy should properly get back whatever information the server gives it in the case of that request and give it to the client. Your proxy should not crash because the request is something that it wasn't expected, and it should not close because it got back something other than what it was expected. That would be a problem. So that's sort of the basic use of telnet there. And I'll show you in a moment how to actually hook it up to your proxy too. But then there's another program that does a similar thing called curl. So curl is sort of just one step higher level than telnet. Telnet's like that basic lowest level. Your browser's the high level stuff. Curl is kind of in the middle, probably closer to telnet. But what curl does is it actually builds the HTTP request for you. So before where we typed the whole GET and HTTP 1.0, this whole line over here, you don't have to do that with curl. So if we did curl example.com, then now we just get back the page already. It just built the HTTP request for us. So if we're just interested in constructing valid requests, if we're done testing that we're able to handle the invalid ones, or we don't want to do something specific, then this is maybe a slightly faster way to get that. And curl will also hook up to your proxy. So we'll get back to those in a moment and use them with the proxy. But how does the web really work? So we've now broken the illusion. If you were under the illusion that the web is only something you access through a browser, really all it is just reading and writing text. It's reading and writing text in the same way that you read and write to files on your hard drive. It's just that they happen to go through the internet with some special format. So a single HTML page. So we saw example.com is really small. The CMU website is actually pretty small too. But lots of websites today have tens or hundreds of files on a single page. They've got images, they've got JavaScript, they've got all sorts of things. So one of the things you're going to be doing in your Proxy Lab is you're going to make it concurrent. So we don't want to have to wait for all of these requests, because if there's 100 things in it, 100 pictures, you don't want to have to load them up one at a time. That's going to be pretty slow. So one of the things you're going to do is make yours concurrent so that it can make all of these requests at once and then take them all at once. And then also this improves caching. So it's much easier to cache parts of a web page than the whole thing, because you've broken up into smaller chunks, and that means that if only part of it changes, you can reload the rest from the cache. You don't have to reload everything. So say you have an image and it's shared by two different parts. If you've cached that image just by itself rather than as part of a much bigger page, you can reuse the cached image and reload only the new parts. So yeah, so here's a excerpt from the CMU website. So this is like something you would get if you ran Telnet on that. So okay, so here's some images. So one of the things you can do in Firefox and Chrome, and as far as I know, any modern browser, is get a web console that gives you information about the requests you're making and how they're happening. So this is what it would look like if you had a sequential proxy. So I don't know, is this Firefox in this screenshot? I think it's Firefox. Oh, this is Safari? Okay, well this is Safari in this screenshot. I can't tell the difference between them. They all look the same. I mean, they do. But this is, okay, so this is Safari in a screenshot. And it's hooked up to a sequential proxy. So someone has started their Proxy Lab. They haven't done the concurrency part, but they've got the proxy part working, just the sequential proxy working. And what you see is it's making these requests. And it makes all of these requests at the same time. And then it has to wait for them to finish before it can go and make the next set of requests. And so you see these big flat lines. And everything is blocked until all of these are done. It can't start making these requests until all of these have finished. Even if it's just waiting for one of them, it can't do anything more. So you're gonna see when you actually write your proxy, if you hook it up to your browser before you have the concurrency part working, you'll actually notice that it's slower than once you get the concurrency part working. You'll notice that it takes longer to load things. Some pages, if you tried like loading up a video, might actually not be able to play at all because it just won't be able to load up the stuff fast enough. So yeah, so we see these requests. They're made in batches, and it has to wait for all of them before it can do anything. But then when we load it up, when we do the concurrent proxy, we see that we're able to make requests that last longer than the next set of requests. So these requests haven't finished until these requests have already been put in, but that's okay because it's concurrent. So, and you see overall everything is actually shorter because they're not all waiting for each other now. Okay, they overlap. So that's concurrency. And we're going to talk more about concurrency in next week's recitation. You should have been talking about it in class too. Let's see, so yeah, so there's this note about Ajax and stuff. You're not going to have to, the point of this is you don't have to worry about it for your proxy. It all just works. You don't have to worry about treating anything like this differently. It just works if you do the right thing. Everything is just an HTTP request. So it will be transparent to you. So some networking basics. So how does this all work? So we have sockets. So what is a socket? A socket is to your program, your C program, it's just a file descriptor that lets the application read and write from the network. So you may have noticed by now the Unix philosophy is to just model everything as files. How do we read and write to actual files on disk? They're files. How do we read and write to these /dev/null, well, let's just pretend it's a file and it throws away the bytes. That was one of the test cases for your shell lab, is where it redirected stuff. The networking is the same. They're all just files to the program. We just treat them a little bit differently in terms of how we're going to set them up, because they are special. But then ultimately, we'll just read and write to them like normal. So you have the client, you have the server, you have two file descriptors, the one that the client has open and the one that the server has open. And you can establish a connection between them. So yeah, the main difference is how you're actually going to get this thing open. So here's a diagram. It does look somewhat complicated, but it's actually not too bad. So there's sort of two parallel things going on. First, the client has to get its file descriptor open. Server has to get its open, and then there's the read-write loop where they're communicating with each other, and then closing it down. So over on the client, there's this system function called getAtterInfo. You're going to be using that. Both the client and the server use that to open up, start to open things up, and then socket is the function that actually gives you a socket. So then the client, all it has to do is once it has a socket, it just connects. You give it, who do you connect to, and it connects to it, and then you're done there. Server has to do a little bit more. The server actually has to bind its socket to a particular IP address and port, so that people know, so that when information comes in on that, it knows that that's the socket that's associated with, and then it has to actually know that it's supposed to be listening for connections coming in on that IP address and port through that socket. So then, it will accept a connection sent by the client. The client uses connect. The server uses accept to say, OK, I'm actually going to open up a communication with this client. And then we have these REO write and read functions. The R stands for redundant I/O, I think. And those, then you can read and write. Each socket is bidirectional. You can read and write on both ends. So the client can write to the server and read back and other way around. And then, eventually you've got close. Just like before, you close your file when you're done with it. And once the server's closed the file, it can go and wait to accept something else on that same socket, a new connection with the new client. So what do these do? So getAtterInfo is the modern way to take in the string representation of the host and the port that you want. So that's like the website name, port number, and actually get a socket structure back from that. There's an old function called getHostByName that this replaces. GetHostByName is unsafe. You should not use it anywhere in your shell lab. You will lose, or shell lab. You shouldn't use it in your proxy lab. You will lose points if you use it. The reason getHostByName is unsafe is because it returns a pointer to a static variable, which means in your concurrent proxy, if you're calling it twice and you call it the second time before you use the results of the first time, the thing that it's pointing to has changed. And so you have to be careful. In order to use it correctly at all, you have to be very careful about making sure that threads aren't modifying it simultaneously. For this lab, we're just saying don't use it at all. We'll take off points if you use it. getAtterInfo does the same thing, except automatically takes care of threading issues, so you don't have to worry about that. Let's see. And then getNameInfo goes the other direction. So you can turn the socket address back into a host and service. So then we've got these functions. So this is going to be a lot like shell lab. We've got these system functions that you'll need to understand how to use, what they do as part of this lab. And you can always read the man pages on them for details. You can always read the textbook for information. Both of those are good places to look. But we've got this API. We've got the socket function, which creates the file descriptor, the socket. Both the clients and the servers are going to use this. We saw in the diagram. And the socket goes both ways, two-way communication. We've got bind. So bind is what associates the socket and an IP address and port number with each other. This is what the server uses so that when people connect on that IP address and port number, it knows which socket it's associated with. We've got listen. So this, again, is just used by the servers. and it lets us actually listen on a connection. We have this backlog parameter, which lets you say how many guys you're going to queue up to wait. And then accept. So accept is used by servers, and that's how you actually you can accept on a socket, accept a connection. Connect is the complement to accept, so the client uses connect and then the server accepts it. Client attempts to connect to this address. It might fail, of course, so you should make sure that your proxies, as in Shell Lab and everything, handle these correctly. If you try to connect to a server and you can't, you should think about what the correct way to handle that is, and the correct way to handle it is not to just shut your proxy down, close it with an error. That would be bad, because then a user just has to put in a website that, put in some sort of malformed input, maybe even just a website that doesn't exist, and everything will close, which isn't the behavior you want. But then, of course, you have close, and close is how you close the sockets once you're done with them. This is the same close that you've used before. And this is just close that takes a file descriptor. Since we're treating these sockets just as files, we've got the same close, we've got the same read and write that we have before. You will be doing reads and writes, though, through the CSAPP package, most likely, unless you write your own wrappers. But we do provide wrappers for you that are better than these ones. You don't have to. That will deal with some of the issues for you. So Proxy Lab itself. Okay, so a byte ordering reminder. So we talked about byte ordering earlier in the semester. This was an issue in like Bomb Lab and Attack Lab, sort of where it showed up. Is that on our 64-bit Intel systems, everything is little endian. And so when we were writing these strings to memory, our attack strings, we had to make sure that the bytes were ordered in little endian order. One thing that's significant is that on the internet, everything is big endian. So it's the opposite order. So if you remember the difference, if we have the bytes 1, 2, 3, 4, 5, 6, 7, 8 in hex and big endian, then this is laid out as 1, 2, 3, 4, 5, 6, 7, 8, which is the opposite of when you were doing your attack lab. This would have, in memory, been ordered 7, 8, 5, 6, 3, 4, 1, 2. So make sure, if anything comes up where endianness matters, where you're expecting bytes to be in a certain order, remember that the internet is now the opposite of what you've gotten used to. It's the thing that probably makes more sense if you don't know either of them. And now that we've trained you to do the thing that doesn't make as much sense, you get to go back to the thing that does make sense, and it'll be confusing because you're not used to it. But that's the way the internet works. So make sure you use that anywhere where it matters. So you're going to write this proxy, and I'm going to show you sort of how to use Telnet with the proxy, use the browser with the proxy. As you go along, there is a driver like before, and the driver will give you some of the points and give you some feedback about whether it's correct or not. But the driver is not at all sufficient for telling you that your proxy is complete. If you get 100% on the driver, that does not mean that you're actually done. It does not mean that you aren't missing any major cases. And one of the best ways to actually test the proxy beyond the driver, and it's also a lot of fun in addition to being useful, is to actually hook up your proxy to your web browser, to tell your web browser to use your proxy and then browse the internet through this piece of software that you wrote. And so when you do that, because of the limits, the limits on what you have to write, you won't be able to browse the entire internet. So you're writing a proxy that handles HTTP requests and just GET. Just GET requests HTTP. For a lot of sites that will work. I don't know if it's actually even the vast majority anymore. Every year it becomes fewer and fewer. This year, as opposed to last year, Reddit has been added to the list of sites that will not work with your proxy because they now use HTTPS by default. So HTTPS is a different protocol and one that you're not required to implement. So your proxy will not be able to browse stuff on Google, YouTube, Reddit, Wikipedia, and the growing list of sites that use HTTPS. You won't be able to do your online banking through your proxy. If you can, you should call your bank and ask them why, because they should be using HTTPS. But some sites that do work, that still use just HTTP, CNN, New York Times, Twitch.tv is actually a good one to test it on because that has videos, and videos are a lot of data, really fast, lots of just binary data, not text. If you're working on, if you get it working on Twitch.tv, that's a good sign that you've got lots of stuff working. This will break a lot of errors that you might have. And also, since you're only doing GET requests, you're not doing POST requests, you won't be able to do any sort of anything that requires logging in or the sort of interactivity. POST is a way that you're sending information to the web server. You won't be able to do a lot of interactive things, more of just static receiving information rather than sending it. And then the second part, so that's the first part is the proxy, the second part is the cache. You should be using something that approximates least recently used. We're not requiring you to do something that's strictly least recently used, but it should be pretty close. Any deviations from it should be just like reasonable deviations based on details of your design. And you must allow for the concurrent reads while maintaining consistency. So the fact that you're having multiple people reading from this cache at the same time, that shouldn't cause any race conditions in terms of what's going on in the cache. Details of that are in the write-up. And the cache is multi-threaded, of course, because if the whole proxy is multi-threaded and the cache is single-threaded, then everything slows down when we have to access the cache, and it sort of defeats the purpose of being multi-threaded. So your cache needs to be multi-threaded, and it should be safe to read data out of it in parallel. In terms of writing, you should think about that. Think about how you're going to design it so that writing doesn't become an issue. There's lots of stuff in the textbook, and I'm sure you'll talk about in lecture if you haven't already. Reader-writer locks and other things that you can use to deal with writing concurrently. We'll deal with writing in this concurrent setting. Okay, so proxies. Right, so this is what we talked about before. Proxies are special because they're sort of in between, and they're a server to the client and a client to the server. In the textbook, there's a couple starter code pieces that might be useful for you to look through to see how things work. A simple echo server that just spits back whatever you give to it, and an example client. Those might be helpful for you to look at. We've got a small tiny.c, so that's just a small web server that might be helpful for you to look at. Tiny.c ignores some things that you have to handle. So that's just as a warning. These are much smaller in scope in what they do. You are supposed to be able to correctly handle cases that these things do not know how to do anything for. But they're a good starting point if you just want to see working examples of this. And then you'll end up with something that looks kind of like this. The proxy's in the middle, the original client and the server on either end of it. And so the client's communicating with the proxy, and the proxy is communicating with the server. Proxy has sockets open both for communicating with its clients and for communicating with the servers that it's communicating with. Does this diagram make sense to everyone? Okay, so summary, step 1, sequential proxy. Step 2, make it concurrent. once you've got the sequential proxy working, that'll be enough to like actually do it through your browser. You can start doing that then. Concurrent, you should see it working better on sites, particularly like the Twitch site probably won't work in your sequential proxy just because it'll be too slow. Once you've got it working with concurrent, then you should be able to see any web page working. If you don't, then you probably, well, any HTTP GET request only website should work. And then add the cache. The cache is somewhat independent of the proxy itself. Everything should work with the concurrent proxy except for, specifically testing the cache. So yeah, so we've got the autograder, the driver. It will, answer some questions about, is my proxy doing the right thing? But it is not at all exhaustive. So I'm going to show you how to hook up Telnet and browser to your proxy so that you can test it more robustly and figure out what's going on. Web is full of special cases for your proxy. So yeah, there's all sorts of websites that you can go to, and if your proxy is wrong, that'll catch it. There's going to be some, there's these scripts. I'll show you how to do those. And there's a brief section on string manipulation in C. But let's work on the proxy a little bit more before we do that. Okay, so I've got two different windows open here, and so I'm going to go to the proxy. Okay, so you've got a couple scripts in your proxy. You'll download it, and there'll be these different things in it. So we've got the driver that tests it. Then we've got these scripts free port and port for user. So these are how you're going to get the port that you're supposed to run your proxy on. Since all of you are writing proxies at the same time, we don't want you running them on the same ports because you can't do that. So to make sure that you all have, a unique port, so that you're not trampling each other and like accidentally sending requests to each other and stuff. Because it's just a proxy server. It takes whatever is there. So if you're sending a request to someone else's proxy, they'll be getting all this information about these requests that are coming in that they didn't send, and they'll think something's terribly wrong. So what we have is we have this port for user script. This is a port that's just for you, and no one else is going to use this for the duration of this lab. You always have this port no matter what. So my port is 7603. There's another one. So if you're, if you want to have two ports in use at the same time, you've got your port, but say you need another one. There's free port, and free port will look at what ports are in use and give you back one that's not being used by anybody right now. And so every time you need a new free port, you need to run this again to check what the currently free ports are. But right now, 4500 is free. So what I have here is I have my proxy. So the usage of the proxy is you just run proxy with the port number. So I'm going to run my proxy on port 4500, which is that free port I got back. And I hit enter, and it starts. And the idea of the proxy is that it keeps running until I stop it. Nothing should close this until I tell it to. But now I have this other terminal open over here. And now I can actually start using my proxy to proxy these requests. So I'm going to use Telnet. So Telnet we used before. Except now, instead of going straight to example.com, I'm actually going to connect up to my proxy. So this was Blue Shark that we were on here. And it's wrapping around all weird because the thing is too small. But we connect up to Blue Shark, which is just blueshark.ics.cs.cmu.edu. Whichever Shark machine you're on, make sure you put the correct Shark name for that. Each machine, of course, has separate ports. And then the port number is now 4500. That's the port number we had for the proxy. So okay, it connected successfully. I'll make that a bit smaller. And so now I can send a GET request. So I'm going to send a GET request for example.com again. And oh, we see over here my proxy has printed out that it made a connection with file descriptor numbered 4. So, you know, I'm not sure why it's 4. 0, 1, and 2 are the 3 normally. I guess 3 is being used. Maybe it already opened up 3 for whatever purposes of its own. Should proxy be printing these? No, that's not part of the requirement. Mine just happens to print out information. It might be useful for your proxy to print out stuff so you know what's going on. We're not testing you on what your proxy is printing, though. So let's see, get example.com, and then we make the HTTP request, and what happens? Well, we have to hit enter twice, remember, because it needs to be terminated by a blank line. And now, okay, so it told me that I was making a request to example.com. The proxy got that request, and it sent it back. And we notice this time it looks like total junk. Like before it was text that we could read, and now it's total junk. And why is that the case? The reason it's total junk is because this is actually a compressed version of the web page. So the proxy has forwarded along my request with headers that told the website that I know how to decompress a page if you send me a gzipped version of it. And so it sent me a gzipped version of it. And that would be perfectly fine if we were in a web browser. It would unzip it for us, and we would see everything normally. The fact that we're dealing with just text, okay, now it looks kind of funny. But you can see content encoding gzip. So this is how we know that the server has gzipped it. That's because of the headers that the proxy is adding to it is the reason it did that. If you removed those headers from the proxy, we could get back the normal text version. But we've successfully proxied the request, and now it's closed. We can do the same thing. Now it's exact same thing if we wanted to. Ooh. So if we wanted to get, the CMU website, we get the CMU website. So here's the CMU website zipped up. So that's one way. You can now test your proxy. So okay, and we see the proxy made a connection and did the request. It knows that it did that. So that's the first way you can test your proxy. And if I sent it, I could send it maybe. I could send it a bad request. Just get something. Okay, so it just tells me host name is invalid from the Proxy Lab web proxy, and then it closed it. So my proxy did not crash because I gave it total garbage, something that it definitely can't actually give me a real web page for. But it just gave me a 400 bad request error, and then the telnet session ended, but the proxy is still running. I could make another connection to the proxy just fine. So your proxy needs to be able to handle bad input like this without actually closing down, because you want your proxy to keep going even when the user puts in something that doesn't exist. So that's good. Okay, so that's using it through telnet. But eventually we want to graduate to something a little bit more exciting and maybe view some pages through Firefox with this proxy. So we're going to actually, part of the grading is that we are going to look in Firefox at some web pages. We give you the 4 web pages we'll look at, you know what they are. But we're going to connect your proxy to Firefox, and we're going to look at 4 pages and make sure that it works right. So it's definitely something you should test, and this is one of the fun parts of the lab. So in Firefox, if you want to test it in Firefox, which is not a bad idea since that's what we'll be doing it in, you can go to Preferences. And in Preferences under Advanced, so Advanced is the last tab of Preferences. It might be opened up to here, but you want to go to that last tab. And then under Connection, so Network Connection Settings. And then there's these options for proxies. So what we want to put in HTTP proxy is the same thing that we were putting into Telnet. So this is Blue Shark, is where I'm currently set up. And it's currently on port 4500. And we can just use the proxy for all protocols. That's fine. Our proxy doesn't actually support the rest of these. But this way, at least, if we try to go to one of those, we'll get an error back from the proxy rather than successfully getting the web page not through the proxy, which might make us think that everything's working when really it's not. So probably better to just say make it work for all of them, and then we can close the settings. And so now we're set up with the proxy. And so now I can go to example.com. And hey, look, I've got example.com. If we went over here, we also see that it loaded up example.com and a couple of icons from example.com. So we successfully made a couple of requests. Or we could go to, the 213. Oh, wait, it's trying to do it in a HTTPS. So you see there, it doesn't work because it's trying to make the secure connection. Can't make the secure connection. Let's see if we can load up the 213 website. Is it going? We can check. It's requesting it. It's taking a while. It shouldn't take this long. My proxy works. I know it does. Yeah, I'm not sure why it's having so much trouble. It keeps trying to get these secure versions of the pages, which is ruining things. Maybe if we go to twitch.tv. Okay, stop. Okay. Well, obviously I have like some debugging to do or something. Maybe I've just no, I haven't lost my internet connection because it's able to get to the proxy. But it knows these requests are coming in. And it should be, giving them back like it did for example.com. You should be seeing the page. Maybe cnn.com will work. I want to show something more interesting than example.com. This is weird. And your browser will keep that proxy setting across sessions, so you'll want to turn it off eventually, once you're not testing your Proxy Lab anymore. Well, that's weird. I'm not sure why it's not working right now. I guess I have some debugging to do. Maybe some of you will have a similar experience. It worked on example.com. We can see that the proxy is getting the request, but it seems like something weird is going on, and we're not getting anything back. But once we have a working proxy, we would be able to browse a subset of the internet with our proxy to test it, and we could just browse for 5 or 10 minutes and make sure that our proxy doesn't crash at some point along the way. That's something you might find, is that once your proxy is almost done but not quite, you'll have missed one condition where it doesn't handle the errors correctly, and so if you browse for a couple minutes, you'll eventually potentially make that come up and notice that there's an issue. The browser is a really good way to test it. So that's hooking up the proxy, using it through Telnet, hooking it up to your browser. A couple other things that will be useful to you for this lab. There's also the driver. I guess I didn't show you that. So now we can finally close the proxy. There's the driver. You run it. It's the same thing as before. Oh, I guess there's no help for it. But OK. So you just run driver like before, and it runs the different things. It's telling me information about what it's doing. It's trying a couple different things, and it gives you back a score. So as you can see here, like it's running fine on the driver, but I'm having issues in Firefox, so maybe something's up. Definitely worth testing in the browser once you've got the basics, once you think you have the basics implemented. So a couple things about string manipulation. So one of the things that you'll have to do in your proxy is you have to deal with these host names and headers, and you want to sort of pull the relevant information out of them as they're coming in. So some string manipulation is useful here. Maybe you saw a little bit of this in reading that file in Cache Lab. You had that file with that information in, and you had to sort of parse some stuff out of it. It's very similar to that. So scanf is a very useful function here. Scanf takes in a string, that's the string you're matching against, and then a format string, which has some sort of pattern. And then you can get, you can match the pieces of the pattern and store them into variables. So if if our string is 213 is awesome, and we give it the format string, I'm expecting an integer, a space, a string, a space, and a string, then I can tell it put the integer in course strings in string 1 and string 2, and what I'll get back is course is equal to the integer 213. String 1 is the word is, string 2 is awesome. Then sprintf is very similar, except it's you print rather than scanning, so it's just the other direction. You can give it a string, give it a format string with some patterns in it for either string or integer, and then you pass in the ones you want, and they get printed out into the string buff. So.
Is it thread safe?
I believe they're thread safe. They're not async signal safe. So that was the issue on Shell Lab, is that these guys, you can't use them in signal handlers because they're not on the list of things that are safe to use in signal handlers, but they are safe to use in threaded programs. Yeah. And you're not writing any signal handlers for Shell Lab, so you don't have to worry about that. Well, I don't know. Maybe you do want to write signal handlers. Who knows? You have to deal with signals somehow. Because you want to make sure you do the right thing for particular signals. But it's not the same as you did for Shell Lab. So then some other functions that might be useful to you. String comparison, the safer version where you actually put in a maximum length so that you don't end up writing something that someone could do attack lab on next semester. That's the problem with these functions that don't take length. They just keep going until they see that null terminating character. That was sort of if you remember in attack lab, that was what allowed you to write those attack strings, is that it would just keep writing until it got to the end, and it didn't know how big the end was. But it was trying to fit into a constant length thing. So these functions are better that take in the length, because then you can match it to the size of your buffer. String length, string copy, those might be useful to you. And then here's the recap on how to actually set up your browser to use your proxy. So we went to the same settings that we just did, and check use it for all protocols. Otherwise, it'll look like it's working on things that it doesn't support because it won't be using it, and you might not notice that you're actually not using your proxy at all. Any questions about Proxy Lab or anything yet?
How do you see which Shark machine you're on?
So it should tell you when you log in which one you logged into. Let's see if I...
It doesn't at least when I'm on pending things.
What did it tell me? Shark to ICS. Maybe it doesn't tell you. I've got my bash configured to dump out the host name into the command prompt.
Echo the host name environment variable.
So just echo host name. Oh yeah, just echo host name, and that'll get it out. So that gives you the full. That actually gives you the full address. So now you just need that in the port. That's exactly what you need to connect to Telnet. Any other questions? That's a good question. No? Okay. Good luck. Have a nice break. We'll talk about concurrency next week.